All right, class. So my name is Michelangelo Bullard, and my topic was linear algebra involvement in game development. All right, so definitions. What is game development? The term game development refers to the process of designing, developing, and releasing a game. On the other hand, we have what is linear algebra? Linear algebra can be defined as a branch of mathematics that is concerned with mathematical structures closed under the operation of addition and scalar multiplication, and that includes the theory of system of linear equations, matrices, determinants, vector spaces, and linear transformations. How is linear algebra involved in game development? Well, firstly, linear algebra, also known as the study in vectors, allow for the change of direction, velocity, and position of an object in game development. It also allows game creators to apply more mathematical characteristics to objects in games, allowing them to be more physically defined. This also allows for manipulations of characters and other objects in game. So basically, because of linear algebra, games are allowed to be more realistic. They're allowed for more mathematical stuff to be applied to them. So example, how would you calculate the speed inside a game? How would you calculate the distance or the damage other characters would face? Linear algebra allows for these things to happen because it allows us to transform linear equations and take them over to the gaming world where we could apply these equations in the gaming process. Here we have some examples. As mentioned, the first thing I said was linear algebra in game development allows for us to see the position, velocity, and direction of an object. Here, what I want you guys to do is start to think of vectors as they would be placed on a graph. So here on position, we have here on the position graph. Here on the position graph, we have a person standing at 2, 1 coordinates on the graph. So basically in gaming, what would happen is this person would be, so basically in gaming, what happens is behind all the graphics and all these other things, the game is just one big graph with players on it. So here on the graph, we'd have a player at the position 2, 1 coordinate, and basically the game would be able to take this data and be able to apply anything to it. And that's how we'd be able to know the position of our player in the game. And that's how the game is able to keep in number and remember where each and every player is at one time, because they're able to record them in a vector space. Secondly is the velocity. As mentioned, because we're able to apply so much mathematical aspects and equations to these vectors, we'd also be able to find the velocity of things inside games. Things, as example, here we have velocities. Most times you would see cars in games. The velocity is speed of a bullet, and in all the type of Call of Duties, the velocity of how high a person jump, all these are allowed because we have vectors. And so what gaming does is gaming would, again, look at the graph, and here we have a plane going in the direction of -2, 3 coordinate, and basically this vector would be calculated. They'll calculate the velocity of this vector by finding the magnitude. And so once we find the velocity of this, let's say we were playing an airplane game, you would be able to, since we have the velocity now, we'd be able to calculate how much gas we need, how fast it's going, what time estimated will it be there, and so these allow the games to be more realistic, as we mentioned before. Lastly, on this right-hand side, we have direction. And so, again, we look at a graph in terms of this vector and behind the whole game. And so we have a gun pointing in 1, 0 coordinate direction, which basically means it's pointing to the right. And so, again, the game takes these coordinates transform them into a vector, and we're able to record the data, and the game is allowed to store this data and manipulate it in any way possible, because linear algebra allows us to keep this vector and store this vector. So as mentioned, I just want to go into more depth about so that you guys can understand. So here I have an example too, and this would be exactly what a game would look like minus the graphics behind it. I'm sure most of you guys play a Mario game before, where you jump up on different stuff, and where you guys jump up on different objects and stuff along that line. And so here, what we have is we have these two people on this graph right here. And so as you can see, the CPU player is standing at the x coordinate 30. And let's say its y coordinate is 1, the same digit, right, the same line right there. And then player 1, this player over here, would be at x coordinate 25, and then y coordinate, let's count, 1, 2, 3, 4, 5, and then he'd be at y coordinate 5. So basically we have one character at 30. Hold for me. So basically we'd have one character at 30 and 1, and then the next character, player 1, would be at 25 and 5. That's what we said. And so what happens is linear algebra allows us to take these two coordinates on the graph, as mentioned before. 1, we're able to know where the players are in the game and on the map. 2, if we needed to move CPU over to player 1, we would be able to find out which direction to go and how far to go based on these coordinates. Because, for example, if CPU needed to go to player 1, basically what you do is subtract his coordinates. What you do is subtract player 1 coordinates from CPU coordinates, and that would leave us with 5 and -4. So basically we'd get that answer, and what we do is apply it to CPU's coordinates, and then we see CPU go back -5 times. Well, not -5, but -5 times, and then he'll go up 5 times just to meet with player 1. And so because we're able to use vector spaces and apply all type of different maths, linear algebra is what makes this possible. Another thing that would be used in this scenario is, as I mentioned, finding the distance. And so it'd be the same process. All you do is subtract player 1 coordinates from CPU's coordinates, and then you would find the length, or you'd find the magnitude, and you'd find the distance. So that's that. On to the next slide. Okay, the thoughts I have on linear algebra. Thoughts I have about linear algebra in game development. Well, during my research and my presentation developing, I realized that linear algebra is honestly linear algebra in terms of game development is honestly a very, very deep and open topic. You could talk about linear algebra and game development in terms of graphics, in terms of play movement, and the way objects respond to each other inside the game. And it also talks about the dimension in type of games. I know for most of you guys that are big in programming or know about games, you heard about two-dimensional games or three-dimensional games. And so linear algebra allows for all these different things to happen. They also allow for rotation of characters in games, uh, transformations of characters in games, as I mentioned before. And it's all because the game is not just storing numbers anymore, but it's storing them as vector spaces. And as we have all realized in class, there's a lot of things you could do with vector spaces in terms of scalar multiplication, dot products, finding the magnitude, which also allows for us to find the distance between objects. And all these things go hand in hand for other physics equations that allows us to find out how much explosion damage would result to a person, depending on how far or how close they are to the object, how much damage would they receive, and so it's because of that linear algebra, we're allowed to calculate all these things in games that allows for games to be and feel more realistic, and what makes us enjoy playing them even more. On to the next. In summary, to summarize, linear algebra is crucial in game development since it covers important math concepts such as linear sets of equations and their transformation properties in mathematics. In mathematics, physics, and engineering, linear algebra is utilized to solve problems. These problems can be seen as in game development. These problems can be seen as the player's direction, location, and velocity. So basically, they solve for these things. And then, as mentioned already, because we have the information such as their direction, location, and velocity, we're able to determine other stuff, as mentioned before, the damage, the distance, how much speed, so you guys get the picture. And linear algebra enables for more universal game production, as well as the inclusion of other mathematical features that make gaming more realistic and correct in terms of physics theory. So in the end, I really feel like because vectors not only allow for gaming to be more universal, for me personally, I believe they made it to seem more, they allow for gaming to be more realistic. Because when you think about it, when we play a game, most times we often compare what that game is like compared to real life. For guys who play 2K, we say, bro, that such things would never happen in real life, or when you're playing a racing game, you'd be like, ooh, I just missed that tree. Now, how did I receive that much damage? Linear algebra allows for all these things to be solved and all these problems to be solved and basically have a realistic answer. Some of the references for the information I gathered was, linear algebra and game development. Here's the link. Definition of game development from Free Code Camp. And the last one was definition of game development, which I got from Merriam-Webster Dictionary. And that is that.